Physics, Atomic Structure 1. Now we come to a very fascinating, very extraordinary fact about the world, that everything is made up of atoms. Now, what is the history of atom? In 460 BC, a Greek philosopher, Democritus, developed a kind of idea of atoms. He looked at things around him and he only felt that. There was no proof for that. That if you go on breaking any material into parts and further parts and further parts, you will have to reach something which can't be broken further. This he called an atom. It was pure speculation and no experimental evidence was available at that time to prove anything. More than 2000 years had to pass before people began to consider the idea of atoms seriously. In the 1800s, an English chemist, John Dalton, did a lot of experiments with several chemicals, and he found a strange thing. Now, this is very important. You must listen to this very carefully. Elements always combined with each other in fixed proportions. Any extra amount added would come out as residue. An element A, for example, would combine with B's by weight, 2 B's by weight. This will always remain true. Suppose element A combines with elements B, and you take the weight of A, you take the weight of B, the ratio would be 1:2. Now this 1:2 ratio will be the same whatever weight of A you take and whatever weight of B you take. The rest will come out as residue. This will always remain true. How can this be possible? Unless some fundamental particle in one element is combining with some fundamental particle in another, the number being always the same. So the weight of the particles being always the same. Thus he proposed that every element was made up of fundamental particles, and he called them by the same name, atoms. So the first turning point came because of the law of definite proportions. When one chemical is combined with another chemical, then they always combined in fixed proportions. Now we come to Thomson's raising in the pudding model of the atom. In 1897, the next great event took place. A negatively charged particle was discovered by J.J. Thomson in his experiments with discharge of gases. He called the negative charged particle electron. He also proposed a model for the atom. Since matter is not negatively charged, he felt that there was a positive charge that balanced the negative charge, and the electrons were put like raisins on a lump of pudding that was a positive charge. So that was his raisin in the pudding model of the atom. Now Berlin proved that when the energy is released when heated until it goes, this energy always comes out as discrete units. That is, it takes only multiples of certain basic values. The energy released when heated comes out in certain discrete basic values. That means only some fixed values come out. The energy was not continuous. He called these energy particles quanta. At that time, light was considered to be a wave, but Albert Einstein thought otherwise. He felt that light was made up of quanta, and he called the quantum of light photon. See the number of discoveries that were being made at that time. Einstein also discovered the photoelectric effect, the phenomenon by which a material gives out electrons when light is put on it and absorbs. By this time, people wondered about light. What was it really, a wave or a particle? Finally, they came to the conclusion that light sometimes behaves as a wave in some circumstances, and at other times behaves as a particle, but never both. Now, this is something very strange in what has been discovered in physics, and that is why many scientists feel that it is still one stage in our discovery of the physical world, which is actually very mysterious. We have not yet fully discovered the full truth. So from what we have discovered, we find that light sometimes behaves as a particle and light behaves sometimes as a wave. The behavior which actually comes out depends upon the setup of the experiment. During the same time, alpha particles were discovered, which had a positive charge. Scientists felt that this was a positive charge in the atom. In 1911, a landmark experiment was performed by Ernest Rutherford. He felt that it would be interesting to bombard atoms with alpha rays. He just wanted to see what would happen. He used radium to generate the alpha particles, and he shone them onto atoms in a thin gold foil. Behind the foil sat a fluorescent screen for which he could observe the alpha particles' impact. A strange thing happened. It was a great turning point in the history of physics. Most of the alpha particles passed through, but occasionally some were hit back as if striking something hard. The only explanation of this was that most of the atoms had empty space in between and with hard points here and there. Rutherford thus proposed his planetary model of the atom. He said that the positive charge was concentrated at the center called the nucleus, and the electrons moved around it like planets. But there was one terrible problem with this model. By that time, a lot had been discovered about electricity and magnetism in general. A negative charge moving around the nucleus should lose energy by generating electromagnetic waves. We have seen that in the last section of electromagnetic waves. Bohr used the principle that energy comes in discrete packets of energy called quanta to come with his model of the atom. So that was the final point which is used by Bohr. He knew that energy comes out in discrete packets. There is only in fixed values the energy comes. Suppose energy is 2, 4, 6. You won't have 2.5. It's something like that. He proposed that only some special orbits are allowed for electrons to move around. He proposed that there are fixed special orbits allowed for electrons to move around. These orbits he called energy levels. When electron gains energy, it jumps from lower to higher orbit. When it loses energy, it jumps from higher to lower. Electron can't have an intermediary between two levels. The energy difference between two levels is the quanta. In 1932, the story went on. Chadwick discovered another subatomic particle called the neutron. The neutron has mass nearly equal to the proton and has no charge. The mass of the nucleus is equal to the sum of the masses of the protons and the neutrons. So this was how the whole picture of the atom came to light, that through the quantum theory on the one hand, through the wave particle duality on the other hand, and so on. So this is a very, very fascinating, very, very interesting aspect of the atom and its discovery and its history. It's clear from this discussion that there are many areas which are still mysterious. Now that completes our atomic structure part 1. In part 2, we will see how the electrons are distributed in the different orbits which Bohr had proposed and which is called the quantum theory. I hope you enjoyed the show. Thank you. Please visit the next section for more details about atomic structure in Physics Atomic Structure 2. Thank you.